interworks with the other features that you have. I'm on the data prep team, and I've been at Tableau for 3 years now. And why is that significant? When I got to Tableau, the way you connected with data is like what you see in that screenshot there. It was very textual. That is a join, if you can believe it. Was there anybody using Tableau at that point? Yeah, we've got a few. Bad old days, right? Starting with version 8.2, data prep became visual. We got a list of your fields in the left pane. You could see the join sitting there. You could see some sample data. So it became a lot easier to work with and actually a lot more Tableau. So why do we need to do data prep? The data that's coming in might be incomplete. This data from Zillow, each table, each file that you read in is just about one type of apartments or houses. And if you want to see an overview of all the data, you have to add in different tables. That's a union process. Sometimes you need to add in different fields, and that's a join process. So doing all of that is the beginning of data prep. The data coming in might be incomprehensible. In this example, what do those field names mean? I have no clue. The values in the fields, those are codes. Those are useless to us unless we do some kind of a translation, more data prep. Finally, the data just might not be in a very good format. It could be a mess as far as Tableau is concerned, and that's actually the primary focus of this talk, is that example. In addition, there can be some additional data prep during the process of analysis to make the analysis process more effective. And you can do it on the fly, same as you do anything else in Tableau. See a need, just go ahead and do it. So the agenda for today is I'm going to talk about putting data into a good format. What is clean data? The process of cleaning and transforming your data. And then once you've done that, getting your viz is quick. After that first example, I'm going to talk with a second example about a few bonus best practices, normalizing data and setting defaults. You've probably seen this before. Tableau shows it a lot. This is the process of doing analysis, starting out with getting data, viewing your data, and finally sharing it with people. But as we all know, life is messy. And while for somebody whose job it is to be a data steward, they might primarily do data prep up front as step 0, quite often you do it as you realize you need it. And it can go in any order. Data prep goes that way, visualization goes that way, and we support that in Tableau. So first of all, transforming data to get into a good format. This is the example we're going to use. This is real data from the U.S. Department of Agriculture about prices of grain. And what if we wanted to understand how the grain prices for different kinds of grain have changed over time? How can we get that from this data? There is no field that's a nice convenient date that we can bring over to our date axis. You just can't get there from here. What you need to do instead is reshape the data into a format that's good for Tableau. Once we've reshaped it, there we have a date field. Nice for the x-axis. We have a price field for the y-axis, and we can put the grains on color or whatever else we want to do to understand our data. So the process of getting the data into a good shape for visualization is what we're talking about. Now I'm going to talk about a preview of what it is we're going to do. Not because you need a roadmap to start with about all of the things you're going to do to get there from here, but just because I want to have you understand in your mind what the different things are, so you get a big picture of what it is that we're doing. So as we're doing the individual steps, it's a little bit clearer, but I don't want to give the impression that you need to look at this spreadsheet and realize all of these different tools and all of these steps that are going to be needed. So what it is we're doing is, first of all, we need to eliminate the extraneous rows of data. Up at the top, there's a title. Down at the bottom, there's some footnotes, extraneous stuff. We need to find the field names. Those are actually in row 3. They're supposed to be in row 1 if you want to get it into Tableau. They're in row 3. What do? There are 3 subtables in this. We need to be able to get those out in order to analyze this well. The way we do those things is with Data Interpreter. It does most of that work, and data source filters can do a little bit of cleanup. Once we've got the 3 subtables, we need to bring them together. Union does that, and the merge mismatched fields command does some cleanup on that too. And finally, we need to get those dates. So we've got to pull those years out from the individual subtables. We need to get the months out of all those different fields, and finally use a date parse function to combine the years and the months into a date that we can use on our x-axis. The result of that is clean data. Clean data is a data set in which each row is a record, a good record, not extraneous stuff. Each field in that record is some independent, clear data that you want, a value that is useful in that record, and they all have clear names, and the values are clear values so that when you have them in the viz, people know what's going on. So now I'm going to switch to a demo. This slide deck that I'm using has screenshots of everything I'm doing in the demo as the next several slides, so you don't need to take detailed notes of what I'm doing. I'm not going to show them here, but I just want you to know that that will be available after the conference. So no need to take notes or anything, but it'll all be available for you. So now I switch over to another screen, and we'll keep on the screen for reference the original Excel file and go to Tableau. Connect to Excel, and this is the USDA 15 Excel file. And actually, when they collected files from me, I gave them both my PowerPoint and the Excel file. So that will be available for download too if you want to actually play with this. Okay, what it read in there looks an awful lot like the original here. The field names it read in was like the first row of the Excel. The first field name is the title of the slide, and the rest are all this useless, F2, F3, and so forth. Got some null rows, finally some interesting stuff in row 3, but these are not good records. Now, this is an intermediate session, so I'm expecting a little help. What's step 1? What should I do first? Anybody? Data interpreter, I heard that, yes. Okay. Now, when Tableau reads in an Excel file, Data Interpreter takes a peek at the file and does an analysis and says, do I think I can help? And if it does think it can help, it puts this little note into the left pane saying, Data Interpreter might be able to improve things for you. If you would like me to do it, check here. So we'll do that. Much improved. So now we've got the different field names from the Excel that it had in the third row of the original. We've gotten rid of a lot of that extraneous stuff. Unfortunately, this still shows the 3 individual tables, but if we look over here in the left pane, there are 3 more tables than we had before, and I'll make this a little bit wider so we can see their whole names. These are the tables that Data Interpreter found, so they're called found tables in the documentation. And the way they're named is for the name of the Excel spreadsheet and the Excel cell names where those tables came from. So this came from A2 to M19. Here's A2 up here and M19 down here. So that's this first subtable from the Excel, and then there's 2 more. So those are the tables that we really need. So let's get rid of that full table and multi-select the subtables and pull them into the join area. Okay? Now you can see that this table pill here is stacked. That's the cue that this is a union, that it's got more than one table, all adding up to be this one set of fields. Let's peek into the union. So the 3 original found tables that I got from the left pane are all here in the union. And we're in the side of the union that's about specific tables. So we dragged in 3 very specific tables, so that's what we have here. I want to point out this other side of the union. This is a feature that was just released in version 10.1 that came out last week. So be sure to download it and check this out. This lets you use a wildcard to specify which tables you want. So if it's blank, that means just include them all. If you want to pick and choose which ones you want, you can say star.csv or star2016.csv or whatever. You specify a pattern there, and it'll bring in those tables, those workbooks, and possibly you can expand to other Excel workbooks and other nearby folders in your file system. We don't need that in this case, but I wanted to point it out just so you're aware since it's so new. In this case, we'll go back to specific tables. Now let's look what we have in our data preview. We've got this 2013 field, which is a lot of nulls. That's not so wonderful. We've got all of these months. Those, it's clear where they came from. 2012, 2011, we'll get back to that. I wanted to highlight these last 2 fields. They are fields that Tableau always generates as part of a union to tell you which Excel sheet and which table it used to create that union, because sometimes important information is embedded like in a file name or a title of some kind and is not available otherwise. For instance, that Zillow data that we had, the file name said how many bedrooms there were, and so that might not be in the data itself. So you need to parse the file name in order to get all the data you need to do your analysis. In this case, we can see that the table names are those names that include the Excel cell names that each of the tables came from. We'll get back to that pretty soon, but in the meantime, let's investigate these years. Let's pull them all together by changing the order of the fields here from data source order to alphabetical, and scroll back to the beginning. Okay, I've got a 2011, 2012, 2013, and if I scroll down I can see 2012 has data in it for a while, 2013 has some for a while, then 2011 has data. How did that happen? That is because when Data Interpreter read in the different tables, it gave the fields the names that it found in the Excel, and each of these got the months, and that was all fine. The months were the same from one table to the next for these, for all 3 tables. So when Union said, oh, this field name is the same, one table, next table, next table, must be the same field. I'll just merge them all together, make one field out of it. But if there are fields that have a different name, this field seems to have the name 2013. Out of the next table, there's a field that has the field name 2012, 2011. I don't know whether this is the same field or not. I will play it safe and make different fields. Now, we can sort of tell that it might be the same field because they have values in them that are mutually exclusive, and nulls where other ones have values. And we know, looking at them, that they all contain the grain data. So what we can do to turn them into one field that's all got grain is multi-select, bring up the menu and say merge mismatched fields. These fields didn't have quite matching names, they were mismatched. We want to merge them. Voila! Now we have a single field, and all of the grains are now all in the same field. Getting better. Now this field is really about grain. So we'll give that name. Cool. So the grain field is good, but oh no, I've lost the years. What do I do for the years? Okay, we have a cue about which of the subtables each of the records came from, and that is these table names from the original Excel. How do we get all of that out? There's various ways. If the actual year were part of this name, it would be very convenient to use the split command. We could just say split. It would throw away all of the text that's in common, and it would make a field for all of the values. So in this case, it would make fields for 21, 38, and so forth. That could get us on our way. Not quite as convenient in this case. It might work very well for the Zillow data, but not in this case. Another idea to try is aliases. Let's actually go into that and see how it might work. So these are the various values that are in the table name field. And we can see that this one goes from A21 to M38, and looking back here we can see, okay, that's really the data that came from 2012. So, whoops. Just say 2012 here. Tab. A2 to M19 was 2013. The other one was 2011. Cool. Are we good to go? If I said okay, yes, all of the values in the table name field would change to those years and it would look good. I actually tried that. I thought that would be a good solution. It turns out it doesn't work. It doesn't work because the way Tableau does aliases is that aliases are just meant for looking good. Make your viz look good, understand that this is really the years or whatever, and it would have nice labels on the axis. But Tableau actually remembers a little bit deeper into the process that these are the original values in that field, and if you do a calculation or other processing on this field, it says, oh, I probably need to use these original values. So if you tried to make a date out of this stuff, it would say, I can't make a date out of U.S. organic grain, whatever. So this doesn't work because aliases happen way at the end of the process, and if you want to use these values in a calc, no go. What will work? Cancel out of that. Turns out groups work great. What groups are meant for is taking a situation where the same value is represented different ways, like things got misspelled. So you have 3 different spellings of Austin, and you want to say, okay, all of these are really Austin, and the right spelling is this, boom. In this case, we don't need to group anything, but the fact that you can rename things lets us fix it for us. So we can say, okay, take this one thing, we're going to make a group of 1. We don't really need to use the grouping feature of this, but we do need to use rename. So A2 to M19 was 2013. Cool. A21 to M38 was 2012. And this other one was 2011. Oops, got to group it. Okay, and this is going to work because it happens early enough in the processing pipeline that it can be used in a calc, and we can go on from there. So now we have a new field, we'll call it year, and it's got our years in it, and now we don't need the table name in the sheet anymore, so we'll make things a little bit cleaner by hiding these puppies. Okay. Looking better?
Can I ask a quick question?
Yeah.
So if you had more grains and the range increased, is this sort of a future-proof solution?
Yeah, the question is this a future-proof solution if more grains appear in the future? given that we're, dependent on the Excel cell names, it might not be. I didn't try that. Yeah, you might need to go in and redo the groups so that the right cell names would go. It might end up just flowing through and working, but I'd have to see for sure if when you reconnect you got longer tables. Certainly if the data changes, it would reconnect and be fine. But yeah, if you ended up with more rows, you might be in trouble.
Why wouldn't pivot have worked?
We're going to get to pivot real soon. Pivot is solving a different problem. We'll do a pivot in a second. Before we get to that, there's one other issue that I'm having with this that I'm not liking so well. Look at that first row. A ton of nulls. That is not clean. That's not a good data row. How did that happen? It's because each of these tables had this one row at the top that's essentially blank except for a little bit of text. And Tableau really wants number values in there, so the text it just kind of threw away, so it's like a whole null row. Not good. Not good to have that here. So the way to handle this is with a data source filter. We use the add command under filters up in the top right corner. Let's add a filter. Now, what do we need to search on to put this filter in? We could search on any of these months and say we don't want null, but for the months, a null value is actually meaningful. You might not have data for April, but you do have data for May. So just because April was null, you don't want to throw away the whole record. But if grain is null, that means the record is pretty useless. You don't know how to interpret it. So let's do a filter on grain and say, if it's null, we want to exclude. Okay. Before I say okay on that, I want to point out that right now we have 48 rows of data. Tracking the number of rows of data you have is a really useful habit to get into because it lets you keep your eye on, are things good? Did something surprising just happen? Was it a good surprise, bad surprise? So we're starting out with 48 and we'll see what we have after that and see if it's a good thing or not. Okay, okay. Now we have 45. Is that a good thing? Given that the Excel had a blank record at the top of each of our 3 subtables, yes, that's expected. We just got rid of 3 blank records. Cool thing. How are we doing? Okay, we've got a grain. We've got the year. And now we have a whole lot of months. And how would we get those months into the x-axis of a chart? This is when you want to pivot. So what pivot is solving for is when you have a whole lot of different fields. They're just completely separate fields, but you want to combine them all together into one field that you want to have on an axis or want to treat together in some way, like being able to put into a calculation to get a date or something like that. So this is what this is a good use of pivot. I want to switch back to PowerPoint just for a second and do more of a dive into pivot to make it a little bit more real in your mind. So I'm skipping over all of those screenshot slides and going to how does pivoting work. Okay, we start out with what we had in this example. We have months as multiple columns and prices as the values in those columns. And what we want to end up with is a month column that we can deal with and a price column as a different field for each record. So we're going from a layout that's essentially horizontal to one that's a lot more vertical. The way Tableau does this is if we start out with the table looking pretty much like the way we have it here, step one is to create a month column and a price column. And then to take each of those fields that we said we wanted to pivot, all of those months, and plop them into the month column. Now this is going to require replicating each of the original records, in this case 12 times, so that there's one for each of the months. So in this example I only did 3 months, so you can see corn appears 3 times, soybeans appears 3 times for each of the months that are in this example. Step 2 is to take the prices that are going out horizontally for each of those months and that grain and transposing them, flipping them. This is where the word pivot comes from, making them vertical and putting them into each of those fields. And then finally, we don't need those original columns anymore. We can just get rid of those, and we end up with grain, a month, and a price. So let's do it. Now, it would be a little bit awkward to multi-select all the way across here. We'd have to scroll, and that's not so good. So this view of the grid here is, we call it the data grid. It's all about showing you a sample set of data, and that's good for a lot of things. But there's another view, that metadata grid, that's more about giving you a more compact overview of your different fields. So since this is not got all the sample data, just shows you your fields and a little bit of information about the fields, makes it a lot easier to do a multi-select. Now here, it becomes a little bit more visible that something awkward has happened with June. How did June end up with month in front of it? Look back at Excel. Okay, in the original Excel, the word month was put into the cell right above June. Now, Data Interpreter said to itself, says Data Interpreter. I wonder if that's significant. Is that something that is part of the word June, or is it completely different stuff? I don't know. I will play it safe and keep that. If the user wants it, they will thank me for it. If they don't want it, there are ways of getting rid of it. So we will get rid of it because we don't need it in this case. We can just edit the name right here. And now we've got just June. We have a record that it was originally month June in the remote field name column. So if I made a mistake and really needed that, I could get back to it. But in this case, it's cool. So I will now do a multi-select. And on any of these, I can say pivot. Boom. I got rid of 12 fields and ended up with 2. Now, Tableau didn't know that I wanted to call them month and price. And pivot field names, pivot field values, that's not really obvious which one is which. So I can switch back to the data grid, see some sample data, and it's totally obvious which is which. Pivot field names, those are the field names from the original. That is what I want as months. And the values from those fields, those are the price in dollars per bushel. Cool. Now, another thing I wanted to point out, I mentioned that it's always good to monitor your number of records. And now we can see that our number of records has ballooned. How did that happen? That's because of flipping from a horizontal layout to a vertical layout. We ended up with a lot more rows. We started out with 45. We multiplied by the number of months. And 45 times 12 is probably around 540. So that's cool. Now we know what a record means is one grain, one date, we're going to make it into a single date pretty soon, and one price. So what a record is really clear at this point. That makes it much, much cleaner data. Okay, last step in the process is turning year and month into a date. Create calculated field. So I will use the date parse function for that. And I like to keep this little cheat sheet open in the calculation dialog box because there's functions like date parse that have sometimes some complicated parameters to them that I don't always remember. And this is telling me that, first of all, I'm going to need it to give it a string to tell it how to interpret the values that I'm sending in. So I'll kind of look at this. I need some Y's and some M's. Okay. Y, 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 Y. And then I'm going to give it a dot, and then M, 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 M. And, okay. And next is a value, the year, followed by a dot, followed by the month. Aha, it says my calculation is valid. Let's check it out and see if it does the right thing. Okay, it gave me a date and time rather than a date. That's real easy to fix. Just change the type right here from date and time to date. Take a peek at it. 2012, April turned into 4/1/12. Cool, looking good. Scroll into 2013, 4/1/13, good. Let's go down to August, 8/1/12, looking good. Now, you might have been a little bit worried about the fact that the formats weren't consistent. Some were 3 letters and a period, and some were, the whole name was written out. Date parse is pretty smart that way and easygoing, and it lets the months be in various formats, and that's very helpful in cases like this. So, we're looking good. Hide the things that we don't need anymore. Are we ready to viz? Let's try it. Go to worksheet. We have a date. We can pull over to the x-axis, and we have months, so let's use them. For the y-axis, let's do price. Okay, that's a mess, but it's adding up all these different grains and whatnot, so it's not very useful. Let's pull grain out onto color. Still not so good. We've got apples and oranges or whatever the grain equivalent is there. So let's get rid of some of this so we can see what's going on a little bit better. We'll filter by grain. Start out with none. And then show the filter. So what grains will we look at? I'm originally from Ohio and grew up with a ton of corn. So let's look at corn. Feed corn and food corn. Interesting. Feed soybean, food soybean. I learned a lot when I did this. I would have thought that food corn was had a lot higher price than feed corn. But I guess not. To a farmer, it looks like food corn and feed corn are about the same price that they get. Food soybean, feed soybean the same way. Who knew? I didn't know. I've learned something. Coolness. As we look at this, another thing to notice is the little indicator down here. Some people call it the null wart. It says we've got 21 nulls. What do we do about that? If we click on it, it gives us a little tool to say, what do you want to do? A couple of choices. If we click on one, it'll make the lines continuous so it looks a little bit better. I want to show you a different way of dealing with it, so I'm doing an undo there. And show you a method of dealing with it that gives you a little bit more control than that little dialogue there. The nulls are in the price field. So if we go to the price axis, we can right-click and say Format. I want to control the format of how these values are being displayed. Switch to Pane, and down at the bottom it says, okay, how do you want to deal with null? These are the choices that you have. Show it indicator means this null indicator. Show it default value. Default value is 0. This is probably not right. This is sort of saying, what would this be if we actually had it? Would the price of everything be zero if it existed? Probably not. So this is not a good way to show it. Hide by connecting the lines. If we believe that the prices are sort of continuous and this makes a better viz, then this is a good way of handling nulls. Just forget the fact that there's some missing data here. Draw your line, skipping over that makes the viz look good, and given the reality of the situation, it may be the right thing to do. A different thing is to say hide and break the lines. And this could be used in other cases where it's important for you to remember, or somebody you're sharing this viz with, to understand where there's data, where there's not data, and be able to see, these grains happen at these times, and maybe certain times of year, certain grains just aren't being grown, so that's why there isn't a price for them, and that would be just fine. This is something that you, as an analyst, can decide based on your own data and how the viz is going to be used. So this is the end of the first example. I want to switch back to PowerPoint and go to a takeaways slide. So what we covered here was several different tools for improving data that started out in a format that really was not good for a data processing tool like Tableau. Data Interpreter got rid of a lot of mess around your data and also found the subordinate tables. Union was able to paste those subordinate tables together, and when it found some tables that had slightly mismatched names, found some fields with mismatched names, merge mismatched fields is the solution to that, to turn them all into a single field. If there's some fields whose data is kind of messy one way or another, there's various tools for fixing that. Split can home in on the actual data. Aliases, groups, calculations can all be used to find the actual data. And then finally, pivot. Take situations where you have a set of fields that are all kind of separate, and you really want them to be a single field as a dimension field that you're going to put on an axis or whatever, and all of the data in them will become a separate field as your values field. After that happens, a record will have a new meaning, and you should sort of be clear on what a record meant before. In our case, it was like 12 different prices, and what a record means now. One grain, one date, one price. We also talked about treatment of null. Data source filters are a great way to get rid of null records, just not have to deal with them. We talked about various ways of displaying them. And then I wanted to mention that there are some cases where none of those solutions are the right answer to null data. You need to think about the data, and depending on what it is that's going on, you might need further analysis. I was reading a paper recently about the recent phenomenon where high school students who are applying to colleges no longer need to supply their SATs all the time. So if you're doing an analysis to try to figure out what the average SAT is to the students that are accepted at a certain college, how do you handle the null data, the students that didn't submit their SAT? Can you assume that the students who didn't submit have the same SAT on average as the students who did? Maybe not. Maybe the kids who are proud of their SAT submit theirs, and the ones who think it might be a detriment don't. And in fact, this paper that I read did the analysis. They were able to get the SAT values. They were working with the ETS, get the SAT values from the other students, and found out that there is quite a difference. And then further analysis would suggest, why is that? It could be, and the reason why some colleges don't require them, some people just don't test well. And it's perfectly fine to accept the students that have lower SATs based on their recommendations and their high school grades and so forth. That's fine. But you just want to know. And in this case, handling nulls as if it were the same as all your other data is not appropriate. You want further analysis. Now I'd like to switch gears and go to a different example and talk about some best practices. Anybody remember this situation? The airliner hit a flock of geese, took out the engines, and Captain Sullenberger successfully landed in the Hudson River. Has anybody seen the movie? Yeah. Good one? Yeah. I've heard that it's good. I haven't seen it yet. But anyway, you can get data on all of the reports of bird strikes in the U.S. from the FAA. Just Google bird hits plane data, and it comes right up, and you can download it. So I'm going to do two examples with this data. First of all, a map viz and talk about normalizing, and then a line chart, a time series, and talk about setting defaults. Back to Tableau. Put these away and bring up our new data. So this is what the data looks like. You can see that there's a lot of information, a ton of different fields, lots of fields. Lots of values. There's been a certain amount of data prep done on this already. This is actually the example that I showed you before that has very difficult to understand field names and values, and I've done some translation already on this. But I mentioned that it's always a good idea to know how many records you're dealing with. And in this case, it says right here that we have 1,000 rows. That's actually 1,000 rows showing in the data grid. And Tableau, in order to keep the data grid with good performance, limits the default number of records here to 1,000. So if you see 1,000 there, there's a good guess that your data set might have more than that. How do you find out how many you actually have if the data grid doesn't tell you? A good way is to come to a sheet. There's all sorts of good things you can do with Tableau sheets. And just pull out number of records onto your viz. You can put it on text. And it's telling us right here we have 170,000 rows. Pretty good data, a ton of it. And we can remember that a record in this case is a strike. So we can rename number of records to just be number of strikes. And rename this tab so that we remember what's going on here. Number of strikes. Okay. Now let's find out a little bit about what's going on with bird strikes in the U.S. Let's find out where it happens. We've got some geographical data here, origin state. Pull it out here. Tableau thinks to itself, oh, geographic data. She probably wants a map. Good thinking, Tableau. And we want to do number of strikes to see what's happening. We'll put that on color code it. Whoa, there's a lot of strikes in Texas. Good thing we all made it. And a lot of strikes in California. What's going on with that? Thinking about this, you see a viz like this a lot. There's an awful lot of vizes that the first time you bring pretty much anything out in a state viz, California and Texas show up, then Florida, New York. What's going on? You bring out superstore sales. You see California, Texas, Florida, New York. Are superstore sales correlated with bird strikes? Not directly. They're both probably correlated with something else, like population. So largely, we may very well be seeing a population effect here and not really seeing what's going on with bird strikes. So a best practice, especially when you see a map like that, you go, oh, I recognize that. Maybe we better normalize and see what else is going on. We'll name this map. And go back to the data source and add in some new data. Remember version 10, we got the ability to add additional connections to a data source. And population data is really easy to find on the web. I pulled it into an Excel spreadsheet and I can just connect to it here, and it's adding an additional connection onto this data source that originally was a bunch of CSV files that have been unioned together and some other Excel. So I now have the red color-coded connection. State populations is the new one that's got the data that I want, and I want to join the origin state, its code with the abbreviation here. And Tableau by default does an inner join. We need to think about whether that's what we want or not. An inner join happens sort of the way that little visual cue suggests that it happens. It only keeps the data that has some common data between the records that are on the left side and the records that are on the right side. So what happened when we did that? Go back to our number of strikes thing, and we've got a smaller number of records than we had before. That's because evidently the state code was left out of some of the records. What do we think about that? Well, if we're doing a viz that's about geography, missing out on state codes is a problem. But, it'll just be kind of left out, even if we do include those. But if we're doing other vizzes, like a time series that we're going to do next, even if we don't know the state information, the other information that's available might still be useful. So we can do a left join to make sure that we keep all of the strike data. And then if we happen to do a geographic viz and it's missing, those will show up as nulls, and that can be okay, but that data will be available for other vizzes. So now we've got the population in here. We need to use it in a calculation to do the normalization, create a calculated field, and this can be like strikes per, well, let's say 100,000 people. So it'll be number of strikes divided by the population times 100,000. Okay. And we're getting the new sample data here. Okay, these are small numbers, and that's because these are per each one record rather than aggregating over the states. So that's okay for the time being. But I also wanted to mention that the population data is per state. And since the states repeat, like here's a couple of Hawaii's population is repeating here. So this field needs to be treated with some care. If we just, did something that summed up all of the population values, and we were hoping to end up with something like the population of the United States, we would be horribly mistaken. All of the states' populations would be replicated per however many times there was a bird strike in that state. So you need to watch out for any data that's replicated like this. Use level of detail calcs or whatever's appropriate in your case to handle that. So now let's go back to our map and let's create a second map just so we can see what changes. Now we've got 2. We'll change the second one and replace number of strikes with strikes per 100,000. Okay, now it looks different. What's dark now? Alaska. Okay, Colorado, Nebraska look kind of dark. What's going on now? area. Yeah. Also maybe rural. More birds in rural areas. So yeah. So let's keep looking. You know, that new one is kind of pastel compared with the one above. Nothing gets as dark as California and Texas. What's up with that? And actually we can see in our key over here, our legend, that it's supposed to get dark, and it goes up to 450, and Alaska here is only 134. Where is it dark? A way we can find out is by selecting everything and then right-clicking and say, View Data. This will give us the data that's being used for this viz. So it's aggregating anything that needs to be aggregated to get the points that are actually in use in this viz. And we can sort this column and see who is big in the strikes per 100,000. Okay, DC. Got it. DC has a fairly small population, but probably a ton of flights per person compared to any place else. So, as with anything Tableau, that just leads on into the next thought about the next analysis we might want to do. It might be all about flights, some combination of flights and being rural and whatnot. So we might want to look for flight data, which turns out it's out there too. But for now, we'll switch gears. But this is an example of looking at one viz, thinking about it, and then doing the next step, in this case normalizing to find out more about what's going on. The final example I want to do is a time series to see how things are changing over time. So I find a date, pull it onto my x-axis, and again, number of strikes. Okay, interesting. Number of bird strikes is going up over time. I've got a low value here. That might just be incomplete data for the last year. Let's get a little bit more information about that. How bad are all of these strikes that seem to be increasing? If we go into Effect, we have a damage field. Pull that onto color. Okay, so what's this top curve that seems to be having so many strikes? Well, the damage was none. That's good news. What's the next curve? Damage, blank. That's null. Okay, that's good news too. If they didn't put anything in there, it must not have been too bad. And then everything else is kind of down at the bottom. So this is actually suggesting that maybe there's a lot more reporting going on of things that didn't really have too bad an effect, but we're just keeping records of them more than possibly we used to do. But as I look at this viz, the color coding isn't so great. Minor is red. These other things, substantial is green, not so good. Let's make the viz a little bit more understandable by editing the colors so it's color-coded better. Let's make destroyed red. Substantial is next, so we'll make it orange. Minor, gold. None, we can make that green. Null, we don't know what that is. Let's make it gray. And then uncertain, who knows what that means. Turn it brown. Now, this viz is a lot easier to read, a lot more natural. We know that green is cool, green is good, and this gray is probably not bad either. So these things that are increasing, no problem. And the red, hugging the axis, that's good news. Not too many planes are actually destroyed in strikes. So now the viz looks good. I'd like to have this color coding be remembered, so the next time I use the amount of damage, I don't have to do this again. Let's set the default properties for this. Default properties, color, Destroyed is red. Substantial is orange. Thank you, Tableau. I set this in my viz and Tableau said, oh, that looks better than the default I automatically created because the user created. I'll remember it as the default for next time. Cool. Good. Another thing I'd like to do is make this legend here a little bit more natural. This is just a jumble of orders here. I could change the order here, sort, but in this, Tableau is not quite consistent. It will not remember it as a default. So I want to go back over to set default properties and set it here so that next time I or anybody else who uses this data source that I'm messing with does this, the key will come out nice. So change to manual, destroyed will be on the bottom, down. Substantial, minor is next, none, and null and uncertain. Done. I set that as the default over here, and now my key automatically got updated for that. And then next time I come along, that will be better. So that's taking your data prep, just doing a little bit in the process of doing an analysis, make it better for the future. Okay. Going back to takeaway slides. So the takeaways for these best practices, normalizing is a good idea. Population is a good thing to normalize by fairly often. Another thing that comes up a lot is if you have financial things that happen over a period of years, you might also want to normalize on inflation or cost of living or whatever. Setting defaults is a good thing. That's something that you can do at any time. It'll just make things better for the future. A couple of sidebars we talked about in the process were doing a left join versus an inner join and keeping track of the number of records you have, making sure that you're keeping the data that you want and not inadvertently losing it. And then in a viz, you can select all, view your data to see some details that might not have been evident in the view that you were looking at. So, summary for the whole talk. The first section was about putting your data into a format for processing. Each record should be a clear data point. Data interpreter and data source filters are good for that. And each field should represent an independent value for to use in your processing. Pivot and those other functions, groups, aliases, split, calculations are good for that. Finally, we talked about some best practices. Interpreter for PDF feature that is being developed right now and should be going into beta sometime soon. And please complete the survey, and if you want to get hold of me, I have the usual email address at Tableau.